everyone, welcome back to the third video in our mini-series on Matplotlib. In this video, we're going to talk about how to display multiple plots. So our goal is we still want to plot y equals cosine now kx for k in this list of integers that I have here, and this is going to be for x between 0 and 2 pi. First thing we're going to do is we're going to plot all of them together on a single axis, and you might think this is a typo and I should have written axis, but here I mean axes as in the axes object. So a single axes object is going to hold all of these plots, and then we're going to have them on multiple axes. As a quick warning before we get started with the video, the plots won't look particularly nice. So today it's really just to show you the syntax and how to deal with multiple plots. And in the last video in this mini-series, we're going to talk about how to make the plots actually look nice and a couple different stylistic choices you can make. So let's get started. Let's start by importing, oops, didn't mean to do that. Let's start by importing numpy as np and also import matplotlib.pyplot as plt. Great, it's imported. Now let's work on the single axes version. So I'm going to have fig, ax equals plt.subplots. And maybe before we go further, I should define this list k. So outside of this cell, I'm going to say k equals 1, 2, 3, 5, 7, 10. Notice there's no nice pattern here, so I can't do this using a range or something like that. But now what I want to do is, so for each value of k, I want to plot cosine kx. So I want to iterate through all of these values. So I'm going to say for k in, and I probably shouldn't call this k, right? Because that's not a very descriptive name. Let's just call it k list. What do I want to do? Well, I want to define this function y equals cosine kx. So we can use a lambda function. So I'm going to say f equals lambda x np.cosine. If I just write kx like this, what's going to happen is Python's going to look for a variable called kx. So I want to include multiplication here because these are two distinct variables, right? I have k and I have x. Now let's also define, well, what's k? Or sorry, what's x? So remember x, we want this to be 0 to 2 pi, and let's do 100 points. So I'll do np.linspace. We're going to start at 0. Go to 2 pi, so this is 2 times, how do I get pi? np.pi. Let's put 100 points. And you might be concerned that I have x defined in 2 places, but because this x here is defined within a function, it's not going to interact at all with this variable x that I have to find out here. So this is looking good so far. Now what do I want to do? I'm going to define my function. I'm going to say, well, y equals f of x. And I'm going to say x.plot x comma y. And let's see. So again, doesn't look very nice, but this is all of the plots, right? So there were 6 elements in k list. So there should be 6 plots here. We can see this one in blue. This looks like a normal cycle of cosine. Then we go up to 2x, so it should travel in double the time, or sorry, it should take, it should do 2 cycles in the same amount of time. So here's 1 cycle, 2 cycles, and you could go through and check that all 6 are there. Good. Again, we'll see how to make this look a lot nicer in an upcoming video, but for now, this is a good example of just the single axes example. How about multiple axes? So what if I wanted to get each one to display in its own figure? Or its own, I should really say its own plot. So notice I haven't been calling anything in this plt.subplots in these parentheses. So let's call help on it and see if I can figure anything out. So plt.subplots. And notice here, the first 2 arguments, number of rows, number of columns, and by default it's set to 1. So what it does is it creates a figure in a set of subplots that fit these dimensions. So here, the default is just 1 by 1. It's a single plot. I want to plot 6 things all together. So I have a choice in the dimensions. How about we make it a 3 by 2? So what I'm going to do is I'm going to say fig, comma, now let's do axs for axes, plural, equals plt dot subplots 3, 2. Now notice for a lot of things that we've done in this class, dimension arguments are usually passed as a tuple, but if we go back to the help that we called, notice the rows and the columns, we pass them as separate arguments. So what happens if we run this? Notice now we get a 3 by 2 kind of layout of these different plots. So could you guess? It might be very surprising what the type of AXS is. And we can see it's a numpy array. So we can ask, well, what's the shape? So AXS dot shape. And we can see here it's 3 by 2. It's the same as the dimensions that we passed in here. So now let's think about the problem at hand. So I want to have a plot of cosine kx for each value of k, where each one lives in these little plots. So I need a way of getting each one. So one thing that I can do is I can call reshape on axes. So axes dot reshape. And if I pass -1, remember that flattens it so that I have this 1, 2, 3, 4, 5, 6. So if I call here dot shape, notice this is just a length 6 numpy array. So what if I call this, I'll do it in a new cell just so that we can still look at this. Didn't mean to do that. Let's call this AXS underscore flat. And notice now what we can do is we can say axes flat of 4, and this returns an axes object for us. So now if I say, let's say axes flat of 4 dot, let's just plot, if I just pass it 3, 1, 4, this is very similar to what's going to happen in MATLAB. So to take a look at it, let's call fig. So remember here we're putting it in the 4th plot, so 0, 1, 2, 3, 4. And what happens here is if I just pass 3, 1, 4, it says first plot 0, 3, then plot 1, 1, then plot 2, 4. So this is what we get here. So notice if I didn't call this axes dot reshape of -1, so for instance, if I just looked at axes and I said something like take 4th entry, I'm going to get an indexing error because it's out of bounds. So remember, axes, what are the dimensions of this? It's 3 by 2 and 4 jumps out of those bounds. So flattening it gives us a way to iterate through each of these mini plots. So kind of with all of this in mind, we're ready to tackle the problem. So I'm going to say fig, axes equals plt dot subplots, again 3 by 2. And I'm going to say for I in range. Now remember, we're going through k-list. So let's say the length of k-list. What's k? Well, k is equal to k-list, take ith entry. What axes are we calling? Well, we're kind of, where are we plotting? It's ax is equal to axs dot flat, or sorry, underscore flat of I. And maybe to make it more robust, what I should do is have this flattened list defined outside of it. So just for good measure, I'll have it here. Good. Now again, same f, same y, so maybe I'll just copy paste those from earlier. All right, looking good, and let's run it and see what happens. Oops, okay, so it looks like there's a mistake here. Let's go through and see if we can figure out what's going wrong. So I think what's going wrong here is I should have defined this inside of here, right? There it goes. So this is exactly what we had wanted to plot. So notice here, this is cosine of x, cosine 2x, 3, 4, 5, 6. So I think this is a good place to end the video. I'm going to have one more video where we're going to talk about how to make this part a little bit nicer. So this isn't perhaps the nicest way of solving this problem. So in the next video, I'll introduce a slightly nicer way, and then we'll get into some of the cosmetic changes that you can make. Thank you for watching, and I'll see you in the next video.